So this is lecture 1 hour today about chemical bonding. In 4 to 5 lecture, we will try to cover chemical bonding whole concept. Then we will solve as much question we can do, because in chemical bonding you have to solve multiple question. You have to know how exactly a VSEPR theory, MOT theory, and how the compounds are going to form. So it is very important because it is the base of inorganic chapter and organic chapter. If you will master the chemical bonding, then organic chemistry and inorganic chemistry both will be easy for you. So now we are going to discuss about chemical bonding. So we have discussed in previous class. Yes, yes, I'm recording. I will share the recordings. I will upload on the YouTube. Yeah. And I will share the notes also. So you don't have to prepare any notes here. This is a short notes. Like this, you have to prepare. We don't have to go deep into every statement, every line. We have to print every statement, every explanation into our mind, in our CPU. We have to print it. We have to just go through the main points and we have to remember it as a notes, right? Mind map like this. We have to print it in our mind. So today we are going to discuss about chemical bonding. Before any chapter, whenever you are starting, let it be physics, let it be chemistry, or let it be bio, or let it be maths, any chapter, the heading, which is the heading of a chapter, it tells us many things about it. That why exactly this chapter is there, why we are learning it. So here chemical bonding, why we are learning? Because what is exactly a chemical bond is? Because it is a force of attraction between atom, molecules, ions, etc. Means how the atom will attract and then form the compound, and force of attraction can be in between atom also, in molecule also, in ion also, etc. So if any assertion reason question comes here, that force of attraction is between whom, it answer will be atom, molecule, ions. But the next point is that why we need a force of attraction? Atom can live by their own, sodium can live by their own, mercury can live by their own, chlorine can live by their own. Why we need exactly the chemical bond? The answer to is to gain a minimum potential energy and maximum stability. In previous class, we have discussed about this point in detail. That whenever there is a relationship in a personal life also or in a chemistry also, we have to relate it directly. Whenever some bond is prepared, whenever there is a relationship between A and B, this is for decreasing the energy to gain the maximum stability. The question is here that whenever we attain a maximum stability, we are gaining a minimum energy. So it is a very important point. It is not like this. Maximum energy you have to gain to get a minimum stability. It is like this. It is inversely related. Stability and energy is inversely related. Stability and energy. Higher the energy, lesser will be the stability. And more the stability, the lesser minimum energy you have to attain. So that's why chemical bonds are formed, because let's say we have a sodium, let's say we have a chlorine. Sodium cannot live by their own because it is highly reactive, and chlorine also same. So what they will do? They will react with each other. They will form the bond, which is NaCl. And what will happen here? It will increase the maximum stability is attained here, and a minimum potential energy is gained here. So that's why NaCl exists like this. So this is the core concept of why the chemical bond is needed. What exactly we need chemical bond? Why exactly we need a maximum stability? So these are inversely related. You have to remember. What is the second point here? While having the force of attraction and gaining the minimum potential energy and maximum stability, we have got a diagram in NCERT, which is very important diagram. We have discussed in previous class. Again, we will see here. When the two molecules, let's say two atoms, let's say atom A and atom B are here, you have to read this diagram not from left to right. You have to read this diagram right to left, first of all. How you have to go? Here, x-axis is what? Distance of separation, and y-axis is energy. Because we have discussed here, about potential energy, maximum stability, and distance between them, because force of attraction. Obviously, whenever there will be a force of attraction, not repulsion here we are talking, whenever there will be a force of attraction, the distance will decrease. So that's why here x-axis we have a distance of separation. So from point X, point Y, point Z, what is happening here? A and B atom getting close together. At a position of a Z, you will see that distance of separation decreased. And when the distance of separation decreased, you will see that a minimum potential energy attained here. This is what? Minimum potential energy. When the minimum potential energy is attained here, you will see that after this position, the graph shooted in an exponential way. Why the graph shooted in the exponential way? Because here I will write it also. Because here what happened? Here till here we have attraction more than repulsion. At this state, when the compound is formed with the help of the atom A and atom B, we have attraction equal to repulsion. And after this, what happened? Repulsion is greater than attraction. So what happened here again? When the repulsion is greater than attraction, energy drastically increased in the exponential way. So if they ask a question related to this, that what happened after the formation of the compound, if we decrease the separation, what is happening here? When we are decreasing the separation, repulsion is greater than attraction, and energy drastically increased in exponential way. This you have to write, or if association question comes, this will be the answer for it. So what is important again here in chemistry, you have to remember the diagram or graphs. Not remember, you have to understand it. You don't have to remember anything in any subject. You have to understand it. What is here figure point 8 saying us? The potential energy curve for the formation of H2 molecule. They have taken this atom A and atom B as H and H, hydrogen and hydrogen, forming the H2 molecule here. As a function of the internuclear distance of the hydrogen atom, what is the meaning of internuclear distance? This is a nucleus, and in between this is the internuclear distance. So this is decreasing here. So that's why they have written internuclear distances. So specifically see, they are mentioning the distance as the internuclear distance. The next is what? Of the hydrogen atom, the minimum in the curve correspond to the most stable state of H2. The minimum in the curve, this is the minimum in the curve where the minimum potential energy is there. What they can ask here again, they will mention here A, B, C, D position. They will ask that which is the minimum potential energy position. What you have to write here? This C, position C. If they ask maximum stability position, maximum stability, what you have to write? Again C, because this is the maximum stability position. So understood this point about the graph and why the chemical bonding happens? Anaya and Rayan? Yeah. So now what next is there? We have understood about why the chemical bonding is happening. Now next point is what here? We have a different type of bonds. Now which are the different type of bonds we have? We have a strong or a weak bond. Obviously, if there is a some bond is happening, obviously it can be a strong or it can be a weak bond. So here also same rule. There are some bond which are strong, there are some bond which are weak. Now the statement only telling us that if it is a strong bond, obviously it will be more stable. So it is again very important point. if they ask you that which type of bond is more stable, obviously strong bond, if someone have a strong bond, obviously it will be more stable because at force of attraction is more. Now what we have, strong bond, we have ionic, covalent, coordinate, metallic. And in weak bond, we have a two types of weak bond, hydrogen and van der Waals. Now, what are these bonds and why these are important? We will see. I have prepared the chart here. So we will see at the end. Till now, just remember that, okay, we have a four type of bond and every bond name telling us about the bond. Ionic is telling us about it because there are formation of the ions. Covalent telling us about this because covalent character is increasing there. We have a coordinate bond. That's why it is a coordinate like this. Metallic bond telling us from its name only that it is made from the metal. Metals are forming the metallic bond. Hydrogen and van der Waals again telling us from the name and what it is we will see in detail. So till now what we are understanding that okay, chemical bonds are forming and types of bonds we have. We have a two type of bond, strong and weak. Next very important point here coming in the story of the chemical bond, which is the octet rule. When the scientists were developing about chemical bonds, what they thought that what is the octet rule? They have discovered that something is similar in every structure, which is a octet rule. They have mentioned it as a octet rule. What is the meaning of octet rule? Rayan, can you tell octet rule from the name itself? See, yeah, yeah, yeah. And how many electron? Yeah. So octet telling us eight clearly, and hydrogen and helium is forming duplet. That's why we have a octet and a duplet. Hydrogen and helium, we have a maximum two electrons filled. We have seen the electronic configuration also. So there we have seen that we have a 1s orbital only, and in 1s orbital, how many electrons can be exist? Only two. So that's why they are forming duplet. We don't have another P or D to increase it. So that's why here hydrogen and helium, if they ask, you don't have to write they form octet. They form duplet. Octet rule is applicable for most of the element, but there are still exception. We will see the limitation of the octet rule. When the octet rule were formed, we know that atom can combine to complete their octet. It is very important because atom combine. Let's say we have a atom and we have a B atom. They combine together, they form the chemical bond to do what? To follow the rule of octet rule. What is the meaning of octet rule? Again, to fill the 8 electron which we have in the valence shell. Now we will see the example. Again, having the octet rule to be followed, we have a two things. We have a two different method to fill the electrons. We have one, transfer of electron. Second, we have a sharing of electron. Again, from the name itself telling us that there is a transfer of electron from A to B position. And here sharing means what? Like we are sharing the coffee or we are sharing a lunch box like this. You can assume. So here what we will do, we will see an example again. Transfer of electron. Here we have a very good example, which is NaCl. What is NaCl again? Na, Ryan, tell me about electronic configuration of sodium. Yeah. Here we have seven. Yeah. Yes. Good, good. So actually here electronic configuration is about 2s2, 2p6, 3s1, and Cl we have a 3s2, 3p5. So whenever you are writing any compound, what you have to do first of all, break it and then write the electronic configuration. That is your first step. whenever in complex structure, in simple structure, anywhere, after drawing, after writing the electronic configuration, what you have to do, you have to see that how many electrons here it need to complete the octet and how many Cl needed. Cl need 1 electron to complete its octet here. Phi is there. I have told in previous class that S we have 2 electron maximum they can accommodate, and P have a 6 electron accommodate. So 5 we need 6 here to fill the valence shell. So here 1 we need plus 1. Why Na need 1? No. Na have complete octet. If you see back subshell, that 2s2, 2p6 we have here, and here we have a 3s1. So what your mind should go, in previous class I have told, I think, that two things you have to every time see whenever you are writing the electronic configuration. After writing the electronic configuration, you have to see 2 points: half filled and full filled. These are most stable state. Very important, very important. This half filled and full filled, most stable state. What is the meaning of half filled? If we have a P, we know that it accommodate 6 electron. What is the P again here? This 1, 2, 3. Make a habit of writing the electron like this: 1, 2, 3. Then you go here 4, 5, 6, like this. What is happening here? 1, 2, 3, 4, 5, 6. So here we have a P. But if you are getting this also 1, 2, 3, this is a half filled. This is half filled. This is full filled. Whenever you are writing the electronic configuration, whenever you are sharing electron, whenever you are transferring electron, you have to check that if I can transfer 1 electron, or if I am getting a 1 electron, if I am transferring 2 electron, or if I am getting a 2 electron, is the condition is filling the full filled condition or a half filled condition? If it is filling, the compound will form in that way. That is a very important point here. So what is happening here? When the NaCl we have, what is the basic here? That we have a 3s1. So you should remember one question here. Okay, we know, okay, transfer of electron, okay, 1 electron will go from here and here, NaCl will form. But what is the basic point here which we are missing? That is, why this 1 electron is going from here to here? Why not here 1 electron is going? First question should come in your mind. Why not 1 electron here? From here it is going here. And why not here 3s1 is there, right? We need one more electron here, 3s2. It will be also complete. But what is the octet rule saying us? We need 8 electron in valence shell. Here we are getting 2, 6, 1. But that is not a point here. Okay, octet rule is there, but we have a multiple limitation in octet rule, remember. But I am telling in a long term that how you will form the compound. We can see here that if we remove the 1 electron here, if we remove 1 electron here, we will get 2s2, 2p6, full filled state. So Na will, what Na will do? It is easier to remove 1 electron for Na. So that's why Na will tell us that no, I will not gain 1 electron. I will remove 1 electron from myself. What Na will do? It will remove 1 electron. 1 electron minus. What chlorine will do here? Chlorine will do, chlorine have a 3s2, 3p5 here. Now what is happening here? 3s2, 3p5. Chlorine will tell us that either I can remove this 5 electron, either I can gain 1 electron. If I remove 5 electron, what we get? We get fulfilled. If I gain 1 electron, again we get a fulfilled. But tell me one thing, why we are doing, that's why I explained you 2 times about this chemical bonding. Why we are doing the chemical bonding? Why we are studying it? Because we need maximum stability. Assume it like this, that chemical, whenever we have elements are lazy, too lazy elements are. So that's why what they are thinking, either shifting this 5 electron, I should gain 1 electron to get a fulfilled orbital. Like this, what happens here, this one electron this one electron goes to here. And what happens, it is a very basic point, that if something is going from here, it is a loss of Na, because one electron is removing from here. So that's why Na will be with plus and Cl will be with minus. So this is very important, Na plus and Cl minus. And that's why how the NaCl forms. And if they say that what is the electronic configuration of Na plus, what is the electronic configuration of Na plus? 2s2 2p6, not 3s1. One is went to Cl. 3s1 will not come. So 2s2 2p6 will be the electronic configuration of Na plus. What will be the electronic configuration of Na? 2s2 2p6 3s1, because I am talking about Na, not Na plus. And if I am talking about a Cl minus, then it will be 3s2 3p6. So again, this is very important. Now, what is the next point? We have a sharing of electron. Okay, we understood about transfer of electron. Now we have a sharing of electron, and in sharing of electron, we have a sharing of a lunch box. We will take one example. Let's say we take a Cl2 example. Let's take Cl here, and here we will draw Cl. Now what I have to draw? I have to draw Cl2. What I will do? I will go from basic point again. Cl and Cl. 2 Cl will be there because Cl2 is there. I will draw Cl and Cl here. What I will do? I will remember the electronic configuration of Cl, and I will see how many valence electrons are present in Cl. So I remember that Cl we have 17 atomic number. If chlorine has a 17 atomic number, what I will do, I hope you know how how we get the valence electron. 2 comma 8 comma, here we have to fill, and we have a 7 only remaining, so we have to fill 7. 2 8 7. So here what 7 is mentioning us, it is a valence electron. How I got 287? From 17 atomic number. So that's why you have to remember all the atomic number of all the element. It is very important, because you have a you have a P block, you have a D block, you have F block also to study. So you should remember every element, and from now you have to start. Then only you can complete it. Means every day make a 5 minute like this short revision of at periodic table. So it will be easier for you. Now what happened here? We know that we have a valence electron of 7. So how I will draw Cl Lewis structure? 1, 2, 3, 4, 5, 6, 7. Like this you have to do every time. Whenever any compound is given, you have to split it. First of all, like let's say H2 is given, you have to draw H2O, let's say given HOH. Then you have to draw your Lewis structure here. You have to draw how many valence electrons are present here. So like this you have to do it. We will see here. Now what happened here? We know that Cl has a valence electron of 7. So that's why I will draw here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now what is happening when I am remembering that yes, Cl2 is there and I have to share electron. I have to share the electron. So what is the meaning of a share of electron that I am making here? I will attach it right here like this. So what is happening here? One electron of this Cl is shared with one electron of this electron, uh, with this chlorine. So two chlorine molecules shared their one electron to form a bond. Now here also one basic point. If one electron and one electron come, this will form a single bond. If here two electron was there and here two electron was there, this one and one will form one bond. This one and one will form one bond. So this will be a double bond. This is single bond. So you have to draw like this. You don't have to mug up which bonds are present in between. 1, 2, 3, 1, 2, 3, 1, 2, 3. This is a triple bond. This is again basic point. Single, double, triple. How it forms. Now we have a single present here. Now what you will ask right now? What question should be there in your mind? Sir, okay, you have mentioned that one and one here. Why not this electron comes here and this electron comes here and form a double bond here? So the answer is that after forming a one bond, we got a stability, which is the octet rule is followed. We got a stability. So why you need another bonds? Why you need to complex? I told one basic point here that elements are lazy. They are too lazy. They don't want to do over complicated things. So that's why here one bond came, stability attained, minimum potential energy attained, game is over. Cl2 formed. Now count the number 1, 2, 3, 4, 5, 6, 7, 8. 8 electron. You will say, sir, why you are adding this one electron? Because it is shared. If I am sharing my lunch box with you, your food and my food will be shared. I will count your food also I ate and my food also you ate. So that's why here lunch box is shared. So that's why here 1, 2, 3, 4, 5, 6, 7, 8. So 8 electron completed of a chlorine. So this followed octet rule, but you don't have to stop here only. You have to check another element also. It is not like this. You will check one element, that's it and done. You will pass to the next question. You can't do like this. You have to check another element also. Now you will see this chlorine. 1, 2, 3, 4, 5, 6, 7, 8. Like this. Okay, so this also pass 8 electron. This also pass 8 electron over. Done. So we understood that, okay, now the octet rule is followed here. Here also octet rule followed because 2 plus 6, 8, and here 2 plus 5, and this one electron came here, 6. 6 plus 2, 8. So here also 8 electron, here also 8 electron, here also 8 electron, here also 8 electron, octet rule followed. What are the two types? You can follow the octet rule, transfer of electron or sharing of electron. Now one more point here, you have to mention it. That is this electron, this one and this two, this electron which are forming the bond, it is called as a bonding electron. It is what? Bonding electron. And it is clearly visible that this 1, 2, 3, 4, 5, 6 of this chlorine and this chlorine 1, 2, 3, 4, 5, 6. These are not participating in any bond formation. So what we will call it as a non-bonding electron. How many bonding electrons are present, Rayan? How many bonding electron? No, no, no. Bonding electron, not bonding bond pair I told. Yeah, good. Anaya, how many non-bonding electron we have in one chlorine? How much? Hello? Yeah, no, no, no. How one? See, bonding electron is two here. This, wait, this one and one, this two. These are participated in bond pair. That's why it is a bonding electron two. How many electron you see that which are not participating in the bond formation? And I see again and tell again how many non-bonding electrons are present. Yes, yes. How many? Yeah, yeah, yeah. Good. Yeah. So it is 6 electrons. So like this, you have to focus that they are asking, because I saw few question here. They are asking either bond pair, or they are either asking bonded electron or bonding electron. So you have to focus what they are asking. If they are asking bond pair, you have to say one. If they are asking bonding electron, then you have to answer two. So it is again very important, and you have to think on it at how bonded pair and bonding electrons are different, and you have to focus on each and every word of your question. So here what happened? Non-bonding electron. Now what is another name of a non-bonding electron? That is lone pair. Later I will make the space here after class. So what happened here? Non-bonding electron is also called as a lone pair. Now tell me, Rayan, how many lone pairs are present here? How many? No, no. How zero? See, non-bonding electrons. How many? Six. What is here? What I am asking? How many lone pairs are present? No. See, non-bonding electron in Cl2. Yeah, yeah, yeah. See, wait. What I will do? I will. Yeah. See, non-bonding electron. How many? Here six. Here six. 12. But what I am telling, non-bonding electrons are also called as a lone pair. And if you see, focus on the name pair. So what is happening here? Two electrons are paired, telling us a one lone pair. So what is happening here? One lone pair. Yeah, right. Six. One, two, three, four, five, six. So how many lone pairs are present? Six lone pairs. So like this, you have to see that how many bond pair, how many bonding electron, how many non-bonding electron, how many lone pair. These are the 4 5 things you have to see whenever you are seeing any structure. Now we have completed about sharing and transfer of electron. Yeah. Now we go with what? Hydrogen and helium. Same thing again. I will not repeat again. Hydrogen and helium forms the duplet. Same thing. Whatever here happening here, they are struggling to get 8 electron, and here hydrogen and helium is struggling for 2 electron. Why they are struggling for 2 electron? Again, every statement you have to ask why. Everywhere you will see that every time teachers say that concept is nothing. You have to just read one line. You have to ask why. You can use your internet. You can ask me anywhere. And that if you get answer of the why, you have to print in your mind. You have to make a flowchart. You have to read it like a node. Like this, you complete your any chapter in any subject. So now what happened here? Hydrogen and helium form duplet. Why they are forming duplet? Why they are struggling for 2 electron and not 8 electron? Because they don't have a shell. How? Yeah, because they have a one s only. They can accommodate only 2 electron. How they will add more 6 electrons here to form the eight? So obviously this is the, and if they ask a question in CBSE, you can answer it. What is the next line again? For second period element. What is the second period element here? This lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. For second period element, central atom can form bond according to their valencies. What is the meaning of this again here? Central atom, whenever there is a structure, let's say H2O. We have oxygen as a central atom, hydrogen as a surrounding atom. Whenever you are drawing any complex structure, not Cl2, not NaCl, I am saying complex structure, more than two elements we have whenever. There we have two things, central atom, surrounding atom. Here oxygen, no, wait, sorry. Here hydrogen, surrounding atom, yeah, and here oxygen. So what is happening here? What it is telling us, for second period element, central atom can form bond according to their valency. So which are this? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Oxygen, let's take an example to understand this. Oxygen. So oxygen, how much is the atomic number of oxygen? Oxygen atomic number 6. No, no, no. 6 is carbon. See, yeah, 8. Oxygen is 8. So yeah, 2 comma 6. So balance how many? 6 electrons. So what the statement is, again we will see, central atom can form bond according to their valency. Valence electron is 6, but valency is how much? Yeah. So that's why you will see that oxygen is forming two bond as a max. It can form one bond also. We will see here again how many oxygen, how different type of oxygens are there forming a different type of bond. But what is the basic statement here telling us? That central atom can form bond according to their valency. If the statement based question comes from here, that central atom can form bond according to their valency, it will be false. You will say, sir, why false? Now you mentioned that it is a true statement. Why it is a false then? Because I have told what central atom can form bond according to their valency, but I not told for which period I am talking about. Then it will be false. But if I mention again one more statement, for second period element, central atom can form bond according to their valency, this will be true, because it happens only in second period element. Because after, you will see later the complexity increases, because D block comes, F block comes, so their complexity increases, and this rule is invalid at that point of time, because we have a different type of valency, so we can't say that yes, it will be compulsory forming the same bonds equal to their valency. We can't say. So that's why for second period element only this generalized statement is applicable. You have to remember that. Now what is the next point here again? What are the limitation of the octet rule? What are the limitation of octet rule? First limitation, hypervalent compound. What are the hypervalent compound first of all means? We have seen right now that what are the valencies of a different type of compound. From the name itself here telling us, hyper means more, hypo means less. So hypervalent from the name itself, yes. Any doubt? What? Yeah. Four limitation. We have hypervalent, hypovalent, odd electron species, inert gas compounds. Four limitation we have. So first limitation is what? Hyper. What is the meaning of limitation first of all? Limitation means that where the octet rule is not followed. So if they are asking that where the octet rule is not followed, you have to answer this four. That's it. So what is happening here? Hypervalent compound. What is the meaning of hypervalent? Again, from the name itself telling us valency is greater than 8. Because we are here struggling to get what? How many electron? 8 electron. So here we have a hyper means more. So valence electron greater than 8. Simple. What is the meaning of hypo then? Valence electron less than 8. That's it. What is the example here? We can see first example. Take PCl5. What is the structure of PCl5 again? Right now you don't know how to draw the structure. let's assume. But we know a basic thing. That's why I started again lecture from the chemical bond. What we know the basic thing, that we are gaining what? Minimum energy to get how much? Maximum stability. So what exactly we are here doing? When we are drawing the PCl5, we know that phosphorus, which is a P, is a central atom. First point is clear. And Cl5 will be the surrounding atom. Second point is clear. We don't know how to draw the PCl5, but we know the basic thing that yes, it will be the central atom. It will be the surrounding atom. Which one? Chlorine. Now what we will do? We will draw PCl5. What I will do? I will put here phosphorus. Now in the phosphorus, if you see that chlorine, we will keep here Cl and here Cl. Why the single bond is coming? Chlorine and phosphorus. Because you have to remember that chlorine, to form the octet, we need only one electron. Or now see the beauty of the formation of the octet rule here, that we have a fluorine, chlorine, bromine, iodine, and why they need a one electron? To have the inert pair configuration. What are the inert pair configuration? Helium, neon, argon, krypton, xenon, radon. These are the inert pair. And this inert pair, what is the use of this inert pair? That they are highly stable. You can't take a neon and simply react with any other element. You can't do, because it is a highly stable elements. And chlorine is gaining one electron here to gain what? To gain argon electronic configuration. That's why chlorine need plus one electron to gain argon configuration. So same here, and that's why if you see, if you focus the beauty of the periodic table, if you want potassium to gain the stability, it will what it will do? It will not gain one electron, because either it can gain one electron to get a calcium electronic configuration, or either they can remove one electron to get argon electronic configuration. So what is the more importance potassium will give? They will remove one electron. Yeah, to give to have a inert pair configuration. So this is the beauty of a periodic table. So how many times you will read the periodic table, you will see this combinations, that what exactly is happening there. So what's chlorine we need? We need one electron to gain inert pair electronic configuration. So what we will do? We will add one chlorine here, add one chlorine here. We know that phosphorus. How much is the valence electron of phosphorus? Yeah. So here we draw one. So what I told, whenever you are writing the compound, you have to mention the valence electron first of all. 1, 2, 3, 4. Here we don't have a space, so I will write here 1. 1, 2, 3, 4, 5. What is happening here again? We have attached the 2 Cl. We need 3 Cl to attach more. What I will do? I will attach. I have a one chance to attach one Cl here. I will attach one Cl here. But tell me one thing, we remain one Cl again. Where I will attach it? So let's say if I attach this one Cl, what will happen here? This electron here and here this electron of Cl, what it will do? It will repel, because like charges repel each other, opposite charges attract each other. So what is happening here? You will say, sir, where this electron came? You know, lone pair. Right now I told these lone pairs are not participating in the bond formation. So they are freely available here. And here the chlorine have free available. So that's why it will repel. So right now you don't know how to draw PCl5. But what is the basic knowledge? What we seen here is, what I will do? I will repel one chlorine here. I will repel one chlorine here. So these two chlorine are apart, good. So it will not fight with each other, and one chlorine will silently sit here. So this is the structure of a PCl5. What happened here again? Phosphorus completed its means valence. All valence are properly applied. We can't add here one more Cl here. We are not adding here one Cl because all valencies are occupied by the chlorine. 5 valencies was there. 1, 2, 3, 4, 5. Now again what happened here? If you see one more point here, I will cover here only. This is the one plane. This is the X plane. It's and chlorine, these two chlorines are there in which plane? This is at a Y plane. So if you have a question, because question can come at first place, that why this chlorine and this chlorine is not repelling each other? Because this is in Y plane. This is it. These are at a X plane. So that's why. So this is the very important point. So you have to, whenever I am seeing this structure right now, I am seeing like this. You have to train your eyes. You have to train your mind to draw the structure like this. So what happened here? Chlorine, 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 chlorine. Now add the number of electrons. How many electrons are present here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will say, sir, why you are adding this? Because sharing of electron is there. So I have to add the lunch box here. So how many phosphorus have 10 electron? How much we need? We need 8 electron. Why this 2 electron more came again here? Because octet rule is not followed by PCl5. So if the question asks that PCl5 is not following the octet rule, why? You have to draw this structure. Then you have to write it that yes, phosphorus is having the 10 electron. Then we need 8 electron according to the octet rule. That's why PCl5 is not following the octet rule. So it is not necessary that all the compound will form the octet rule. So what happened here? Hypervalent compound we have seen about a PCl5. There are multiple examples. You can go one by one example and draw it with your hands on your rough book. And then you can ask me that, sir, I am not getting this structure. I am not getting why this is hypervalent called, why this is hypovalent called. Then I will tell you about it. Now what happened here again? We have a hypovalent compound. Hypovalent compound is what? Valence electron less than 8. Yeah. So valence electron is what? Less than 8 electron. Okay, one point is what here? One more point here. You missed one point here. What? Which point? You not asked me why. Sir, why PCl5 have here 10 electron? How is it possible? First of all, if hydrogen and helium you told that one s was there and here 2 electron can accommodate, they don't have a more than 2 electrons. They are not forming the octet, they are forming duplet first of all. So why the phosphorus is, how phosphorus is going to attach 10 electron with it, accommodate 10 electron with it? Because the reason is, if you see, if you focus on the hypervalent component in physics also, you will see in physics semiconductor chapter in 12th standard. In semiconductor chapter, there are the points on this hypervalent, hypovalent. We have a different type of semiconductors. So what is happening here? If you focus on the phosphorus, if you focus on the sulfur, because there are the structure, I will write it here, SF6. There it is. Yeah, SF6. SF6. We have another structure also, which is H2SO4. It is not simple like PCl5SF6. H2SO4 is complex structure. H2SO4. So what is happening here? If you see, if you focus on these 2 points, sulfur, phosphorus, sulfur, and if you go into the periodic table, phosphorus, sulfur, phosphorus, sulfur, phosphorus, sulfur, what you are seeing here? You are seeing the third period. And if you are seeing the third period, you know that we have vacant d orbital present here. So I will write the reason also here. Reason vacant d orbital. Rayan, explain me why I told this reason vacant d orbital here in a hypervalent compound. Why I told you a reason that vacant d orbital due to the vacant d orbital hypervalent compound not follow the octet rule. What is the reason? Yeah, they exceed more than 8 electron due to vacant d orbital. But why hydrogen and helium was not present? Yeah, hydrogen helium was not doing it because they don't have a vacant d orbital. Yeah, but phosphorus, sulfur, the third period have a vacant d orbital. If you write the electronic configuration, you will see that d orbital is unfilled. And that's why here more electrons can accommodate. So this will be your reason like this. That's why hypervalent compounds are formed here. Now what is the next point? Hypovalent compound. So same thing you have to do again and again. So I will write here what BCl, BF3, BCl3. You can write anything. Let's write BF3. You can write AlCl3. You can write LiCl. Now again see the beauty of the periodic table. If you are seeing the boron, if you are seeing the aluminium, if you are seeing the lithium, they are again from this one period only, which is second period. So that's why I'm telling you right now that third period is forming the hypervalent compound because they have a vacant d orbital. But second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they are forming the hypovalent compound. Why? Because they don't have enough shell to accommodate electrons. So that's why if you write, if you have a question that sir, how I will draw BF3, how I will draw LiCl. So see LiCl simple, you can see here that it is ionic compound clearly plus and here minus. Cl has a minus charge, Li has a plus charge. This is the ionic compound, ionic bond. Which bond it is? Ionic bond. Why ionic bond? Because ions are formed. What is the meaning of ion? Plus and minus charge ion. Yes. How the BF3 is there? Boron. What is the hydrogen, helium, lithium, beryllium, boron? 5. 2 comma 3. Valence electron how much? 3. We have a boron here present. 1, 2, 3. This one electron will share its lunchbox with one electron of fluorine. One bond. Here also same one bond. Here also same one bond. Now you will say, sir, tell me like this. I don't know how to draw the structure. Tell me about BF3 now. How I will draw BF3? Yes. What is the reason of drawing this structure in a pyramid form like this? Yeah, repulsion. Because here we have electrons. Yes, yes, good. So we have electron here present, we have electron here present. It will repel. So that's why you can't draw BF3 like this. If you are thinking that, okay, I will write BF3 like this. So we can't draw. Also, then lone pair also will come here. But here we don't have a lone pair. So that's why it is not coming. But in another structure, like let's take example of, or we will see later. Here we have examples present. Or let's take here only. NS3, let's take NS3. How the NS3 is forming here? And 5 electrons are present. 1, 2, 3, 4, 5. First, your what you will do? You will draw the valence. Yeah, lone pair valence electron you will draw. Then what you will do? You will draw here H, one electron H need. So we will draw one, one. NS3 formed. Now what will happen? Here we have a one lone pair missed. One lone pair. We don't. It is untouched. It is not participating in the bond formation, that's what is called as a lone pair. So if they ask the question, how many lone pairs are present in NH3, answer will be 1. How many bond pairs are present in NH3? 3. How many bonded electrons are present in NH3? We have a 6. How many non-bonding electrons are present in NH3? We have a 2, because this 1, 2. Electrons and pair, you have to remember every time. Now what is happening here? This lone pair will repel. So how the structure of NH3 will form? And this pair of a lone pair will be like this. And like this will repel the hydrogen. So you can't put hydrogen like this. So here hydrogen will come after repelling, and one hydrogen will come here, opposite. One hydrogen I will attach opposite to the lone pair, and one hydrogen I was thinking to attach like this, and it is right also. But what happened? Lone pair repelled the electron of hydrogen and shifted the position here. So when you will learn about the VSEPR theory, you don't have to remember the structure. You can draw by your own only. So you don't have to mug up anything in chemical bonding chapter. You have to go basic points only. So what happened here? Hypovalent compound, done. Same thing. Again, you can go with AlCl3, you can go with a LiCl3. Now we have a odd electron species. What is the meaning of odd electron species? First, we'll take example NO, NO2, ClO3, ClO2. Odd electron species are very easy, and many time question have come in the NEET exam, that they give the four option. They give the four option and they tell us that which element, which compound, so not element, which compound is odd electron species. And it is very easy, 4 marks in NEET exam, very easy. So what we will do here, we will read about odd electron species. We will take one example. Let's say we take a example of NO. First of all, what we will do, we will write NO. We know that nitrogen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Carbon is 6, nitrogen is 7, oxygen is 8. 7, 8, 2 comma 5, 2 comma 6. So we know that a nitrogen has a valency of valence electron 5, oxygen have a valence electron 6. So nitrogen will be like this, 1, 2, 3, 4, 5. Oxygen will be like this, 1, 2, 3, 4, 5, 6. So this is the main basic point. Now what we have to do, we have to attach nitrogen and oxygen. So what I will do, I will see that nitrogen and oxygen is present. And here what we are thinking, that odd electron. First of all, we will see odd electron. What does the odd electron mean? That how many valence electrons are present. So if we see NO, then molecule or atom has an unpaired electron which occur when there is an odd total number of valence electrons. And how many valence electrons are there here? 5. And how many are here present? 6. And 6 plus 5 you will do, you will get 11. And what is 11? Odd. NO2, let's take example of NO2. Here I will put, here what is the valence electron? 5. Here 6. Here 6. 5 plus 6 plus 6, 70. So like this you have to, what you have to do? Very easy, very simple 4-mark question in NEET exam. Whenever you get a compound, break it, write the valence electron, add it. If it is odd, it is odd electron species. That's it. And after writing multiple times, you don't have to do these steps. If it is coming in the NEET exam, obviously I am not writing these things. I will directly see NO 5 plus 6, 11. Tick. How many seconds it took? 3 seconds. 1, 2. Maximum you will take 10 seconds. 10 seconds per option. 4 option is present. 1, 2, 3, 4 option. So you will get 10 seconds, 10 seconds, 10 seconds, 10, 40 seconds. Question solved. Also, next point is what? After seeing the NO, NO2, ClO2, ClO3, this will be the only the option. These 3, 4 options are present and it will be present from the 4 option. You just have to tick directly. So like this, you can decrease the time of solving the question. what we are seeing here. Yeah. Okay, one thing we missed here, that about how we draw the structure. NO2. NO2 we have no, NO2 not. Yeah, NO2, let's see NO2 only. Here we have. So what I will do, or let's take NO here, where it is here. So what is simple? Same thing again. You don't have to use your mind also here. 5 valence electron here, 6 valence electron. You have to follow what? N here O. We need here one electron here and one electron here. We draw the one bond. Again, what we will do? We have seen that again octet stability is not attained. If stability is not attained, oxygen can form another bond also. We know. So that's why here one more and one more. Here one. Now what? Nitrogen is having 1, 2, 3 because fourth and fifth electron is added here. 1, 2. So here 1, 2, 3, 4. So here 6 completed and here 2. So 6 plus 2, 8. And here 1, 2, 3, 4, 5, 6, 7. Here 7 only. So now you see that is the octet rule followed? No. Why? Because nitrogen is having the 7 electron only. But according to octet rule, both should have 8 electron. But what you are seeing here, oxygen is following 8 electron. Octet rule is followed by oxygen. But nitrogen, yeah, 7 electron is there only. That's why octet rule is also not followed in odd electron species. That's why it is a limitation. And from this line, what we have seen till now about how we will know that what are the odd electron species, one question can come. Second question, what it can come from here, that structure is following octet rule or not. So whenever you will see odd electron species, directly you will cut the option that it is not following the octet rule. So here 2 to 3 question is forming from the single line. Next is what? Inert pair compound. Now again, inert pair compound is what? Inert gas. Sorry, not pair, inert gas. So inert gas, we have seen that we have a helium to radon. So inert gas compound is what? Again here it forms with oxygen and fluorine. First one. This is OF, it is not the about the compound forming. It is the inert gas with oxygen or inert gas with fluorine. Means like this. Example C. Xe, this is the inert gas. F2, XeO, F3. What is happening here? Oxygen, fluorine with inert gas. Krypton, F2, like this. So these are the inert gas compound, and if you draw the inert gas compound, how we will draw inert gas compound? Again, same thing. Yeah, but what happens here? Inert gas have a stable electronic configuration. They cannot form the compound directly. But we have a different ways to form the compound of xenon and then helium. Also, we have the ability, but we need the external conditions here to form this. So this is a good question that why the XeF2 is forming, because we have right now learned that Xe is already a highly stable element. Why the Xe need to be stable? But in an external condition, we can as a giving the external condition, we can form the XeF2 compound. So what is happening here? XeF2, how you will draw? Xe. How many electron valence? 1, 2, 3, 4, 5, 6, 7, 8. We know it because it is highly stabilized. So F2, F here, 1 bond will come here, 1 bond will come here. So what will happen here? 3 and 3 here, 2 form. So what I will do here? Xe, F, F, and here 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So here 2, sorry. What will happen here again? See the method of drawing the structure again. We have a two lone pairs. So how I will draw it? Here one lone pair, here one lone pair. It will repel each other. and Fe will go little bit, not too much, little bit there. And one point is very important here. You mentioned, yeah, yeah, it will repel. But if you see the structure clearly, that we have a two lone pairs here at downside, so it has a more power to repel it. So what will happen here? Xe, here one lone pair is present, right? Here two lone pair. So I will draw two lone pair like this. It is repelled. So lone pairs is cleared here. What we have to do? We have to draw the two fluorine. So what I will do here, fluorine. So this will be the exact structure of XeF2. So what is happening here? This lone pair equally shifted here, the fluorine position, and this lone pair also shifted here. But what is the power? Whenever we have a more than two, more than three lone pair present in any compound, we have to see which one is more powerful. We have a more cloud density. You have, I think, in structure of atom, you have seen about the electron cloud. We have a here electron cloud present. Electron cloud. So if we have electron cloud present here, more power it will generate to repel it, more repulsion here. And here what is happening here? It is a less electron cloud than below one. That's why it has a lesser power of repulsion. So that's why fluorine shifted where? Here. So this you have to focus. The physics you have to apply here little bit. That which force is powerful more. You have completed NLM chapter in physics, Newton's laws of motion. NLM chapter completed in physics. No, Newton law of motion is there, right? No, gravitational chapter is another. Newton laws of motion is there. Chapter. Yeah, yeah, yeah. So same rule you have to apply here. Force, where the force is more powerful, like this you have to draw. Where the force is more powerful, where the less force will be there, it will shift there, like this. So yeah. So now this is over. So these are the limitation of odd electron species. So when if they no, not odd electron, octet rule. So octet rule limitation is what? Hypervalent compound, hypovalent compound, odd electron species, inert gas compound, which forms with the help of oxygen and fluorine only. Remember. So here these four things are not following octet rule. So that's why octet rule is not every time applicable. So this is the main point. So next last statement is what? Octet rule not explain shape of molecule. First point, which is a conclusion statement of a limitation point. Conclusion statement. Octet rule not explain shape of molecule. First point. Whatever I am drawing here, chlorine like this is not told by the octet rule. Octet rule just tells, okay, 8 electrons are there. That's it. But how the repulsion is going on, they are not telling us. So explain shape of molecule, not explain, right? And not explain what? Relative stability of a molecules. They're very important. What is the meaning of relative stability of molecule? Again, same thing that if they are not explaining us the shape of molecule, how they will explain the stability of the molecule? Because stability is not like this. That like this you will draw XCN, here one, here one, here one lone pair. Octet rule is telling us like this. But we have to see the shape of the molecule also. We have to see where the exactly lone pair is present. That's why if they ask a question that why the octet rule is not followed, because octet rule not explain shape of molecule and not explain relative stability of molecule. This is the important, right? And that's why we got a new thing which is a VSEPR theory. Again, there is a limitation in VSEPR theory. That's why we got a MOT then. This is again a story. See, chemistry is also like a story. First came octet rule, and we saw the octet rule, and limitation was present. So scientists went to form the VSEPR theory. VSEPR theory also have a limitation. That's why scientists went to MOT, and finally we got MOT, which explain about stability. That's why we have to go. We have completed one part. Then we will complete VSCPR. Then we will complete MOT. My aim was to complete formal charge also, but okay, we have completed major part, which is the octet rule. In next class, we will see about a formal charge, which is very important because you should know how to find out the formal charge. And then one more point is there, which is about a different type of bonds. So this point. So you don't worry. We will discuss about what is ionic bond, what is covalent bond, because this should be clear in your mind that what exactly ionic means, what exactly covalent means, why we are forming metallic bonds, why the hydrogen bond and van der Waals force is the weakest force, weakest bond. So that's why we will complete in next class. Any doubt here in today class? Yeah. Okay. Yeah. Okay. So we will close the session today. On Monday, we will take class every day, Monday to Saturday, every day Monday. Yeah. Okay. Okay. So in the afternoon. Okay. Yeah. Okay. 3:30 means Indian time, 5 o'clock. No, you are telling IST time or UAE time, Rayan. Okay. 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 So which time is suitable then? Raya, it will be okay at 6 p.m. 4:30. Okay. 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 Fine. Yeah. 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 Okay. Sure. Okay. So we will end the class from Monday. We will do. Right. Okay.